All right, you guys, next lesson, 1-3 in our Tennessee Revealed Geometry, line segments. This is an important lesson. You have to realize that things connect to make longer segments and lines. Our vocabulary for today is line segment, betweenness of points, congruent, and congruent segments. You're going to see that word congruent, the entire semester long in geometry, or a year if you're taking it at a school that does it for a year. But congruent, everything's going to be congruent. Congruent this, congruent that. It means they're the same length, same measure, that sort of thing. All right, looks like it starts off with an online activity, which, if your teacher wants you to do that, do it. But I'm going to start right here where it says learn the betweenness of points and what a line segment is. Basically, it's part of a line that has a measure to it. So we learned last time that a line extends indefinitely in two directions, but a line segment actually has 2 points. Those are your endpoints on each side, and you're looking at how long it is, what's the measure of it, what's the distance from one point to the next point. Next up is betweenness of points. Doesn't necessarily mean it's in the middle. It just means it's between the 2 points, like literally between them. So here's a great, example over here. You got X, which is an endpoint, Z, which is an endpoint. Those make up your endpoints, your segment, X, Z. But you got this little Y right there. It's a point that is between X and Z. Not necessarily in the middle, just between them. So I love giving this question to my students, and it's a trick question. I'll give them something that looks like this before I even start the lesson, and I'll ask them, look, how many segments do you see? Oh, I see 2. I see X, Y, and I see Y, Z, and I'm like, well, that's true. There is an X, Y, and there is a Y, Z, but there's also an X, Z. There are 3 segments here. And the reason why you can say that is because the 2 that you named, the 11.3XY and the 3.8YZ, will add to make the length of XZ. So that trick question kind of leads them into seeing why there are 3 segments there. All right, so let's look at example number 1. There's your addition. It's probably can't really see that, but it's a segment addition postulate is actually what it is. All right, it says find the measure of XZ, which is the third segment after you get combining. All right, so let's see. I'm going to add the 2 I said together and get XZ, which is your third one. So XY is going to be the 11.3. And I'm filling in a blank for YZ, which is the 3.8. And you're probably going to need a calculator to add those together. I'm sure there's probably a built-in one here. I just don't know where it is. So grab you a calculator. If you don't have one, you get 15.1 centimeters. All right, moving on. Looks like we got a check for understanding. Find the measure of DF. Oh, I did this one earlier and I forgot to take it off. Well, there you go. There's your answer. So to find DF, because that is the length of the 2 segments added together, 2 7/10 plus 5 9/10. You got lucky. I left the answer in and I didn't really mean to do it. 8 3/5. And I think that is going to be, we're going on to the next page. So let me turn my page in my book I'm looking at. Example number 2. All right. Excuse me. Find the measure of QR. QR is the right part. Oh, okay. So what they do is they give me the left part and they give me the entire segment. So instead of adding the 2 that they give me to find the big third, this time I've got the length of the whole thing. I'm going to do a little subtraction. So PQ plus QR is PR. So PQ is 6 5/8. So let's see, I got to go here to get a mixed number. So I'm going to put a 6 in front and 5 in the top, 8 in the bottom. So I'm going to hit accept, put that in there. So 6 5/8 for PQ. QR is what we're looking for, and PR goes right here, which is the 13 3/4. And go back here again, click this in the front, 13, top 3, bottom 4, and I'm going to hit accept. And of course, it tells you that we're going to do a subtraction. So you guys that had Algebra 1, the opposite of adding 6 and 5/8, you learned was to subtract 6 and 5/8. So grab you a calculator, put in 13 and 3/4, and then subtract 6 and 5/8. So 13 and 3/4, and you're going to hit your subtraction button and put in 6 and 5/8. And looks like, okay, well, listen, mine gave me an improper fraction. Now, your teacher, that might be okay. Improper fraction, I got 57/8. An improper fraction is when your top number is bigger than your bottom number. So your numerator is bigger than your denominator. I got 57/8. If your teacher's great with that, put in 57/8. If they want it as a mixed number because this is a mixed number, then yeah, change it to a mixed number. And that's going to be 7 1/8. So go here, 7 and 1/8, and hit accept. So moral of the story is, if they give you the two parts, you add them. If they give you the entire thing, you subtract them to find the other part. All right, very good. Looks like I've got a check for understanding coming up. Looks like there's some extra stuff in here. You check your solution for x. I guess that's extra that's maybe in the computer program. Let's go down to check here. That's what's in your notebook. All right, find the measure of PQ, round your answer to the nearest tenth if necessary. The nearest tenth is one number after the decimal. Okay, once again, I am looking for the left side. PQ is blank. I have been given the right side, QR, and I've been given the whole, PR. So this, again, is a what? Add, addition, or subtraction? Yep, it's a subtraction. So I'm going to put in 24.3 minus 17.8. And I get 6.5, which is automatically rounded to the nearest tenth because, again, the nearest tenth is one number after the decimal. Okay, so looks like I need to move on to the next one. All right, example number 3 in your book. Write and solve equations to find measurements. Okay, so we are going to solve an equation here. So step 1 says plot 2 points, label them A and C, connect the points. And B is between A and C, so they put it right there. Now, again, you're not going to really know what between is specifically. Is it closer to A? Is it closer to C? Is it in the middle? Who knows? It just says between. All right. So, but I am a visual person. So when it says AC is 4x minus 12, I'm going to put a 4x minus 12 and, like this person did, a line to the A, a line to the C. So my students see this all the way across. All right. AB is X. That's going to be that little part right there. And BC is 2x plus 3, that big part over here. All right. And of course, this is the segment addition postulate. It means you're adding because you have both of the little parts that adds to equal the big part. Remember that trick question. How many segments do you see? I see 3. AB, BC, and then add them to get AC. All right, here we go. AC is 4x minus 12. Got that big part. And you add the AB and the BC. So the AB was the X. There it is, visual people. BC is 2x plus 3. There it is, visual people. And it looks like they want me to combine like terms. What they mean, you guys, is 1x plus 2x is 3x. Everything else just comes on down. Haven't done anything with the 4x minus 12. Haven't done anything with this plus 3. All right, they want me to subtract 3x the other side. Very well. So minus 3x over here, minus 3x from the 4x leaves me an x. Bring down your minus 12, bring down your 3. And the last step, add 12 to the other side. So the opposite of subtracting 12 is to add 12. Well, 3 plus 12 is 15. There you go. Got that one done. Oh, Love geometry. And honestly, you guys, this will get you on the ACT if you are not paying attention to what the problem's asking for. Well, the problem may not just ask for, hey, find x. They may ask for, what's the length of BC? They may ask for, what's the length of AB, which is your x. They may ask you to find AC. Well, you guys, that is a plug and chug. In other words, you're going to take your 15 and you're going to plug it in. So it's not just 2x plus 3. It's going to be 2 times 15 plus 3. All right, so given the x is 15, you plug it in. Well, 2 times 15, remember you always multiply before you add and subtract. I know you've heard that, please excuse my dear Aunt Sally stuff your algebra teacher made you learn. Yes, here it is again. 2 times 15 is 30, plus the 3 is 33. All right. What we got here? Think about it. All right, so it looks like that's one of our things that's online. You know, another example, go online, get you an extra example. Or ask your teacher. What we got here? Apply example 4. Use betweenness of points. All right, Space Needle. Daryl is visiting the Space Needle in Seattle, Washington. He knows that the total height of the Space Needle is 605 feet. The distance from the ground to the observation deck is 10 feet more than 6 times the distance. Oh, don't you just love it when they use words? All right, of the Space Needle, help Daryl find the distance from the ground to the observation deck. All right, so it looks like we got to describe in our own words what we're doing here. And then if you have any questions or anything, we need to, I guess, ask those. But all right, basically you're doing this. You're trying to find an equation to find what they're asking for. But here's where people get stuck. Is this 10 feet more than 6 times the distance of their observation deck? We don't even know what the distance of the observation deck is. So that is going to be your x. The distance of the observation deck is your x. 6 times that is going to be 6x. More means to add. So you're going to add 10. So you're looking at 6x plus 10. That is your entire equation. Plus your x, which is your observation deck. We don't know what that is, but we know the whole thing is 605. Okay, so that is your task. You're going to need to put that in your own words. I'm not sure how you want to describe that, but that is actually what we're doing. So I'm assuming that down here, oh, okay, yeah, it's just like the book. I got kind of stuck in what they were wanting here. So the task is we need to find the distance from the ground to the observation deck. And then how does that compare to the total height? You need to put that in your own words. How will you approach it? Well, of course, you need to set up an equation that represents the total height of the Space Needle. That is your observation deck with your 6x plus 10 that I just talked about. So you need to have it basically in your own words for that to happen, but it is a segment addition thing. It's going to be your observation deck plus the tower is the whole 605, because I have a feeling that's what's about to come down here. All right, here's our strategy. We know the entire thing is 605 feet. That's what's going to go for your total. I do not know the length of the observation deck. That's going to be your x. And then here comes your 6 times the length of the observation deck plus, because that's what more means, 10. That's what's going to go right there. So the equation they want, okay, segment addition postulate. You're going to take your observation deck length. You're going to add in your 6 times the observation plus 10 feet. And we know it's a total of 605 feet. So there is, oh, that doesn't really give you the whole thing. I don't like that. I like to be able to see the whole thing. And you can't see the whole thing in this, which that's not good. All right, now they want you to solve the equation. And that's going to be kind of hard to do, but you're going to add like terms. So you're looking at 7x plus 10 is 605. And then, subtract 2 on the other side and divide by 7. Put that on your paper, you guys. It's going to be 520 feet if I did my math right. All right. And of course, if you're sitting in a class, it's going to be a lot easier for your teacher to show that to you. Write about it. Argument, defend your solution. Well, shoot, plug it back in and see if it works. Yeah, just plug it back in. 520. See if it works. All right. Good deal. So take your X, plug it in, get 520, boom, you're done. I guess put that in your own words. What do we got? Next page. Oh, here comes the congruent part. Okay, you guys, see those little tick marks right there? That little red tick mark and that little red tick mark means that those are the same lengths. They're both 1.7 from A to B and CD. We call these congruent segments. That means they have the same length, the same measure, the same stuff. All right, so we say congruent. Now I want you guys to look over here. See this little symbol right there? You're going to see that on the ACT. It means that the two things that you are comparing are congruent to each other. They're the same measure, the same length, the same distance. All right, so let's see what we got next. Oh, good. They've shown you different things. I like that. So this 1/ and 1/ are congruent. This 2/ and 2/ are congruent. So EF and GH are congruent. And the segment KL, which is a 3/, is congruent to segment IJ, which is a 3/. I very much like that. And I use that in my geometry class to show 1/s are equal to 1/. 2 is congruent to 2. 3 is congruent to 3. Okay. Example number 5. All right, write and solve an equation using this congruent. Well, they're marked equal, you guys. If that PQ, which is 6x plus 20, has a little 1/, and this QR, which is marked 2 times x plus 6, has a 1/, they are congruent to each other. You put an equals in between, which is what they've done here. Okay. Write the justification. Well, that is what we were given, which is a typical proof. You're writing down what was given, but since they changed from congruent to equals, I'm going to assume that definition of congruent is going to go right there. So definition of congruent. And I wish that would let you actually see it. It needs to be stretched out some. All right, definition of congruent. Got that done. All right, what have they done next? Let's see. They brought down the 6x plus 20. They distributed. 2 times x is 2x. 2 times 6 is 12. Oh, my bad. I'm skipping a step. This is distributive. This is what they've done a substitution. They've taken PQ out and they replaced it with 6x plus 20. They took QR away and they replaced it with what it is, 2 times x plus 6. That is a substitution. You guys, I got ahead of myself. So this is my distributive. All right, so after they distributed, looks like they did something. Oh, they moved 2x to the other side by subtracting. So the opposite of adding 2x is subtract it to the other side. So this is going to be your subtraction. So subtract 2x to the other side. Simplified, I'm going to put subtract. So subtract 2x to the other side. Looks like they combine like terms because 6x minus 2x is 4x. And 2x minus 2x does cancel out. So I've already used a substitution. So I guess they just want me to say simplify, which I don't like. I don't like the word simplify here. It's a little too vague for me, but yeah, I'm going to go with it because that's our choice. All right. Oh, here we go with the subtraction again. Subtract 20 to the other side. Subtract 20. So it's going to be subtract 20 to the other side. Subtract 20. Put that there. All right. Then they combine like terms again. So I guess they're going to want me to use simplify. Again, I don't like the word simplify, but I'll go with it. Simplify. 4, 5. All right, next step. Oh, looks at it. The opposite of multiplying by 4 is to divide by 4. So they are definitely dividing each side by 4. So divide. And again, they just simplified. Negative 8 divided by 4. Yeah, that's going to be, I guess, a simplify again. Simplify. All right. We don't do a lot of proofs anymore in Tennessee. They're not in the curriculum. So I'm kind of surprised this one like that, but hey, I'm going to go with it. Equal versus congruent. All right. Lengths are equal and segments are congruent. I actually like that very much. That's very much true. Congruent means same length, same measure, same distance. All right, I like that. All right, want to check. All right, find the value of x. U is between, which means U has to be the one that's added, and TV is going to be the length of all of it. All right, so TU. Oh, looks okay, guys. It says it's congruent. So these are going to be set equal to each other. So if they are congruent to each other, you're going to set 7x plus 35 equal to the 4 times x minus, plus 7. So set them equal to each other, you guys. Set them equal. You're going to end up doing your distributive over here, just like you did with this problem. Move stuff to the other side by either adding or subtracting. You know what? Let me work out this problem real quick. So that's going to be 4x plus 28. All right, I'm going to subtract 28 to the other. No, I'm not. I'm going to subtract 4 to the other side to get 3x. I'll subtract 35 to the other side. Looks like my number is going to be negative. I'm going to divide by the 3. All right, it is. It's negative. So put a little negative sign there. And again, I got an improper fraction. I got a negative 7/3. So 7 on top, 3 on the bottom. Or if your teacher wants it as an improper fraction, that'd be negative 1. No, negative 2 and 1/3. Negative 2 and 1/3. All right, you got another example online if you need to see it. And it looks like practice is up next. So, woo-woo, I am done with this lesson. All right, fantastic, you guys. Ask your teacher questions. If you're in my class, ask me questions.